Students, welcome to the video. Our today's topic is addition of vectors. Students, since vectors are the physical quantities that require a proper direction, so they cannot be added like ordinary numbers. They are having a specific method for addition. That is the graphical method, and it is known as head to tail rule of vector additions. Students, the steps which are involved in this process of addition of vectors are: number 1, select a suitable scale. Means, to graphically represent a vector, first of all we will select a scale on which we will draw the straight line which is representing the magnitude of that vector. Number 2, according to this scale we will graphically draw lines for all the given vectors. This is the second step. And third step is very simple, that these vectors will be joined by head to tail rule. Students, according to this rule, vectors will be joined such that where the first vector ends, there the second vector starts. Means, head of the first is joined with tail of the other, keeping in your mind the directions of two vectors should not alter. And the last step is to get the resultant. Student, when vectors are added, the answer is not called sum of the vectors. The answer is called resultant of the vectors. So how we will get answer? Means, how we will get the resultant of the two vectors when they are added? What we will do? Join tail of the first with head of the last. Students, it is not necessary that there should be two vectors. There can be many vectors. So we will keep on joining them by this head to tail rule, and at the end the resultant is obtained by joining the tail of the first with head of the last. Now let us clear these steps one by one. We consider an example in which a person, say a news seller or any other salesman, moved 120 meter eastward. It is his first displacement, and took a turn and moved 90 meter towards north. Keep in your mind, first displacement was toward east and second displacement is towards north. The value or magnitude of the first displacement was 120 and second is 90. So what is the displacement from starting point? Means, what is his total displacement? Students, now step 1. What we will do? First of all, we will mention a specific direction. Say this arrow is representing the direction of north. Second step will be the suitable scale. Then we will select a scale that suits us, means the given value and the available space on the paper. Say in this situation, let 1 centimeter represents 30 meter, because 30 is a number that divides over both the values 90 and 120 equally, completely. Let 1 centimeter represents 30 meter. Means 30 meter displacement on the ground is represented by 1 centimeter length of a line on paper. Now, according to this scale, what we will do? Step 3. We will represent the given vectors on this scale graphically like this. These lines, keep in your mind, are not according to a scale. These are just for making the concept clear. Say first was the displacement of 4 centimeter towards east. Here is the direction of east. So we draw a line of 4 centimeter length representing the displacement of 120 meter towards east. Let this vector is represented by A. Similarly, the second displacement was 90 meter towards north. 3 centimeter length in the direction of north and it is represented by B. What was the next step? These vectors, now they are A and B are two vectors representing the displacements. They are joined by head to tail rule. Means where the one vector ends, there the second starts. Students, you are free to select any vector as a one vector and any vector as a second vector. There is no restriction. Look at this diagram. Here, where A ends, there B starts. But direction should not be altered. Here, B ends, there A starts. You can consider any of the situation. So that was the step. Join the vectors by head to tail rule. Here the vectors are joined by head to tail rule. Lastly, what we will do to get the resultant of these two vectors. When these two vectors are added, what will be our answer? Here we call that answer as resultant. To get resultant, we join tail of the first vector with head of the last vector. Look at this diagram. First vector was A, second vector was B. To get the resultant, tail of A is joined with head of B, or in second situation, tail of B is joined with head of the A, and this is called resultant. Students, addition of vector, I told you, is different from additions of numbers because numbers are scalars and vectors need direction. Students, if A and B were numbers, then it is clear that their sum means A plus B would be 4 plus 3, 7. But here we obtained A plus B 5, not 7. So this shows that the addition of vectors is different from additions of number because directions are involved. So addition of vector is different from that of numbers. These are directed quantities, and when we add vectors, we consider their directions also. So it is different from addition of numbers. Numbers were 4 and 3 magnitudes I am talking about. So 4 plus 3 should be 7. But no, here it is 4 plus 3, 5 centimeter. This is the graphical method. Students, thank you for sparing your time to see the video. If you liked the video, don't forget to subscribe the channel. Take care of you. Goodbye.